So we're going to start this lesson by looking at three different equations. We have y equals 2x, y equals 2x minus 1, and y equals 2x plus 3. So notice just by looking at these equations that the rate in each of these, the number in front of x, or the coefficient to x, is the same. They're all 2x. Now, what's different about them is the number that's being added or subtracted each time. So in the first one, we don't have any number being added or subtracted, so it's understood that it would be plus 0. In the second, we have a minus 1, and in the third, we have a plus 3. So I'm going to take each of these equations and separately plug them in on my graphing calculator in the y equals spot and look at these tables to see how and what points I can plot. So let's start with this first equation, y equals 2x. If I plug that in my calculator, I see a list of points. I have negative 2, negative 4, and then negative 1, negative 2, 0, 0, 1, 2, 2, 4, 3, 6, and 4, 8. So I'm going to go ahead and plot those points now. The first point I have negative 2, negative 4 would be right here. We have negative 1, negative 2, 0, 0, 1, 2, 2, 4, and I could continue. I could go to 3, 6, and 4, 8. So that gets me several points on my graph. Now, rule of thumb is as long as you have 3, you're good to go. So let's go ahead and connect these points to make our line. So my line for this equation would look something like this. Now let's get rid of this table here, and let's look at the second equation, y equals 2x minus 1. So this time my points have changed slightly. If I plug in y equals 2x minus 1 into my equals spot on my calculator, I can look and see these new values for x and y. So I'm going to plot these points now. So the first point is at negative 2, 5, which is actually going to be just below this first point that I plotted on the other one. The second point we have is at negative 1, negative 3. Then we have 0, negative 1, and then 1, 1, and 2, 3, 3, 5, and 4, 7. And again, those are all really, really close to that line. I'm going to go ahead and connect the dots to show this line now. Okay, so now let's go ahead and get rid of this graph as well, or this table, and let's look at the third one, the last one. We have y equals 2x plus 3. So I'm going to go ahead and plug that into my calculator and look at this table. So in looking at this table now, we have a new set of points to plot. The first point we're going to plot is at negative 2, negative 1. Then we have negative 1, positive 1, 0, 3, 1, 5, 2, 7, 3, 9, and I'm not going to be able to get that 4, 11 on there just because that's where my graph stops. So let's go ahead and connect these dots to see what this line looks like. Now, the most important thing in determining the relationship between these three lines is looking to see what types of lines they are. And since they're side by side, they line up right next to each other, we call these parallel lines. So when it says to describe what you notice about the lines, I want you to tell me that they are parallel lines. Now, the second question, it asks, what do these lines have in common? And basically, we've kind of already talked about that. We've talked about looking at their equations and seeing how each of them has a 2x in it. So therefore, the coefficient to the x is the same in each of these. Therefore, when you're determining what they have in common, we say that they have the same coefficient and they also have the same steepness. Now, there is a relationship between the coefficient and the steepness of the line, and they're the same steepness again because they're parallel. They're going in the same direction and they are right side by side each other. Now, these lines are different because of their y-intercepts. They do not start at the same spot. So we determine their difference by saying they have different y-intercepts. And again, we determined based on the equations that they had different numbers being added or subtracted each time. So we want to make note of that too because again, there's this connection. So we say they have different y-intercepts and different numbers added or subtracted to the x value. Now, to determine the rule for these lines, again, we want to look at what's consistent, what's the same. And the rule here is if they have the same coefficient, then these lines will be parallel. So I can abbreviate this. Same coefficient means they're parallel. And again, that would be the rule for this type of equation. So anytime you see that two equations have the same number in front of x, you need to automatically know that they will be parallel lines. Okay, so let's check out this second equation, or the second group of equations. So in this one here, we have y equals 2x and y equals negative 1/2 x. So remember, we already graphed that y equals 2x. I could again plug this in on my graphing calculator and look at the points in my table. Okay, so if I plug it into my calculator, these are the set of points that I get from my table. So let's go ahead and plot these points. We have -3 and -6, which would be about here. -2, -4, then -1, -2, 0, 0, 1, 2, 2, 4, and 3, 6. And again, remember, go ahead and connect the dots to see what the line looks like. All right, so we're going to do the same thing with the second equation now. So let's go ahead and get rid of this table. And now let's look at the table for y equals negative 1/2 x. Remember, when we plug this in on our calculator, we want to plug in -1 divided by 2. That's a fraction. All right, so this time when we will look at the table, we're going to notice that we have several decimals. And sometimes it's kind of hard to graph decimals. So because of that, we don't have to. We can always just graph our whole numbers. So I'm actually going to start this one at -4 and a +2. So we're going to go over 4 and then up 2 for the first point. The next one I'm going to plot is at -2, 1. And then we have 0, 0. And then to -1. And I'm going to go ahead and continue this pattern of 4 and then -2. So that'll get us a few points for this line, and we'll go ahead and connect them and show that the points continue. Okay, so when we look to see what type of line these are, we're looking at the angle that they make when they connect. And if you notice, they're forming a perfectly right angle. We can see that this makes a box here. And therefore, because they're forming a right angle, they are actually perpendicular lines. So these type of lines are perpendicular, meaning again, they make a right angle. So again, to describe, they are perpendicular lines. They make a right angle. Now the second question, what do these lines have in common? And for that, I'm going to look at the graph. So notice that they cross the y-axis at the same spot. They're crossing at the very center, which is 0, 0. So they have the same y-intercept. And remember, we talked about from the last one how we can see that y-intercept being added or subtracted to our equation. Notice that in both of these equations, we don't have a number that's being added or subtracted. Therefore, it's technically +0 in each equation if I had to write something. So that's again why they cross at the y-axis. Now, how are they different? They have very different rates at which they're increasing. One is increasing by 2, the other is increasing by a -1/2, or I should say decreasing by a -1/2. So they're very different coefficients to x, and therefore different rates. And again, in noticing their differences, one is increasing by 2, and the other is decreasing by a -1/2. So we want to determine a rule for this to see if any type of line or any type of two lines are going to be perpendicular lines. And the rule here is this. We take the first coefficient to x and we make it the opposite and the reciprocal. And that's this. I'll tell you what I mean by that in just a second. So again, the rule, perpendicular lines will have opposite reciprocal coefficients. So here's what I mean by opposite. First of all, when I say a positive, the opposite of that would be a negative. So it's going to basically be the opposite sign. And what I mean by the reciprocal is when we take a fraction and we flip it upside down. So let me give you an example for a reciprocal. So let's say that I start with a coefficient of 4. So we'll say our coefficient then is 4. And technically, we have to put it over something, so it'd be 4 over 1. And again, I'm assuming that this is a positive. So the opposite of that would be to make this a negative. And when I flip it, I flip the 4 and the 1, and it becomes a -1 over 4. So again, if I were given this slope initially, it would turn into this. So this would be the first rate, this would be the second rate. So we flip the fraction. Let me give you another example. So let's say that I have a negative 2 over 3 to start with. When I make it the opposite, it's going to turn into a positive. And again, I'm going to flip the fraction, so it's going to become then 3 over 2. So this is what I mean. Anytime we see an opposite and a reciprocal coefficient to x, it's going to have perpendicular lines. All right, let's look at a different one now. So here we have very simple equations. We have y equals x and y equals negative x. So really the only difference is one has a positive x and the other has a negative x. Now understand that when we don't have a number in front of the x, it's understood to be a 1. So actually my coefficients here are 1 and negative 1. So I'm going to plug each of these in again into my calculator and look at the points that I can plot on my graph. All right, so we're going to start with y equals 1x. So let's plot these on our graph. So the first point we have is negative 4, then negative 3, negative 2, negative 1, 1, 0, 0, 1, 1, and 2, 2. And again, you can kind of see the pattern here. Obviously, it would keep going. Let's go ahead and connect these dots to form our line. And again, we're going to show that it continues by putting arrows at either end here. Now I'm going to do the same thing with the negative x now. So let's get rid of this table and let's look at y equals negative x. All right, so for this one, it's kind of the opposite as we would expect because again, one's positive and the other's negative. So here our first point is at negative 4, 4. So that'd be negative 4 and then up 4. And then we have negative 3, negative 2, negative 2, negative 2, 2, negative 1, 1, 0, 0, 1, negative 1, 2, negative 2, and we probably could continue to go, and again, you should see the pattern here. So we'll go ahead and connect this one as well and form our line, and this time, notice that we're going the opposite direction. Now, again, we are going to decide what we see about these lines, and you should notice, again, they are perpendicular, and they follow the same rule as last time. So again, when we describe what we notice, we can say again that they are perpendicular lines. They follow the same rule as before. We start with our first coefficient, which is a positive 1, and it would be technically over 1. And the second coefficient is a negative, and again, the reciprocal of 1 over 1 is still 1 over 1. So they are opposite reciprocal coefficients. Now, when it asks, what do these lines have in common? Well, again, they cross the y-axis at the same point, so therefore they have the same y-intercept. So again, how are they different? They have, or what do they have in common? They have the same y-intercept, and again, it crosses at the origin at 0, 0. So we see that cross here. Now, how are the lines different on this one? Well, for one is increasing, the other is decreasing. And we notice again from the equations, one is a positive x and the other is a negative x. So again, the biggest difference I want you to notice is that one line is increasing, the other line is decreasing. That's going to help us form our rule for this one. So just like when we were talking about correlations, when we have a positive coefficient to the x, it's going to be increasing. When we have a negative coefficient to the x, it's going to be decreasing. So again, that's a pretty easy rule that you need to know. Again, a positive coefficient of positive x will increase, where a negative x or negative coefficient to x will decrease the line. And you will need to know that just by looking at the equation. All right, so this is the last set that we need to identify. We have in this two equations again. One is y equals 4 and the other is x equals negative 3. These lines are pretty easy when you know what they look like, but kind of tricky at first in learning them. So know that when we have an equation such as this first one, y equals 4, there is no x value. So it doesn't matter what the x is, the y is always going to be 4. Therefore, I'm going to look on my y-axis here, and I'm going to plot every line at 4, where y is 4. So I'm going to go up to positive 4, and again, I'm going to plot every point where y is 4. So what this looks like is a horizontal line. And again, if I connected that, I would see that this line is a constant at a positive 4 where the y is. Now, there's a trick to remember this one. when we have a flat line like this and it's just a y equals a number, I want you to think y lies. He's lazy and he lies down on the graph. Therefore, it's a horizontal line. Now, kind of the opposite of that with the x, when we have x equals -3, we're going to only look at where our x values are -3. So therefore, on my x-axis, I'm going to go to -3. So I'm going to plot -3. I'm going to put every single point where we have x is -3. And again, I could connect that line too. And this time what you're going to see is it is actually a vertical line at -3, where x is -3. This one I want you to think that this stands like x stands like a soldier. He's standing straight up and down. So therefore, it's a vertical line. Now, when we're noticing about these lines, there's no increase or decrease in them. They are both constant lines. So again, they're constant lines. There's no rate of change here. There's no specific values that it's increasing by or decreasing by. It's simply constant. The number is not changing. Now, what do these lines have in common? Well, they only have one number. It's either y equals a number or x equals a number. So there is no two variables in this one. So again, they have in common they're constant lines. There's no increase or decrease. And they just have a y equals a number and x equals a number. Now, they're different because, again, one is horizontal and the other is vertical. And again, this leads us to our rule for these. So our rule is when we have horizontal lines, we're going to have y equals and just one number. And then we also have x equals a number, and that's going to lead us to a vertical line. So again, rules to keep in mind, when you have just y equals a number or x equals a number, it's not going to have any change of rate of change in the line. It's a constant line, and it's either constant horizontal or constant vertical. So we have y is a constant number and x is a vertical.